So solve the equation on the interval zero is less than or equal to theta, which is less than 2 pi. All right, so what I want you guys to think about is, I mean, you guys are in PreCal. The only thing different between this and what you guys have solved before in the past is it's sine squared and sine instead of x squared. Do you guys agree if it was 2x squared minus 3x plus 1, we have different strategies to solve that, right? So what I want you guys to think about is this is really just 2x squared minus 3x plus 1 is equal to 0. Then we could try to either factor this, or if you guys aren't comfortable with factoring this way, you guys technically could use quadratic formula if you really wanted to, right? This does factor though. So is there a GCF? No, so what was the strategy for factoring then first? Yeah, A times C. So I'm gonna multiply my 2 times my positive 1. So I'm looking for two numbers that multiply to give me 2. But when I add them, I get negative 3. Negative 2 and negative 1, good. Now, do you guys remember, then we would rewrite this by using these numbers. Do you guys remember that from last semester? So we would write 2x squared. Then instead of writing negative 3x, I'm going to use these numbers. So minus 2x minus 1x plus 1. Because these numbers come from these numbers. And I'm going to warn you guys are really good about this. When I say stuff like this, I feel like you guys take me seriously, which is good. Something like this is guaranteed to be on your test. So if you guys don't know how to factor, please don't use Schmodosh or OpenAI or anything like that to do your homework, because you will not be able to solve this on a test if you guys can't factor, okay? Do you guys remember now that we break this up into 2 terms and 2 terms? What could I take out of both these? 2x. So it's going to be 2x times x minus 1. And then to factor this, I'm going to take my parentheses, copy paste. What would go here so that way when I multiply it, I get negative 1x. Negative 1. And then if I just check my math, negative 1 times negative 1, isn't that positive 1? So we're good. Okay, so do you guys remember then the parentheses that matches would be one of your factors. And then the other factor, do you guys agree, would just be the stuff that's on the outside? So that's going to be 2x minus 1. And then this goes there. And remember, this all equals 0. Okay, is everyone comfortable? Now, are we really solving for x though? What was x in this problem? Sine. Sine of what? Theta. Okay, so I'm going to replace now, use sine of theta is equal to x. So instead of writing x minus 1, it's really sine of theta minus 1 times 2 sine of theta minus 1 is equal to 0. And then I'm going to solve that equation. Okay, two factors times each other equals 0. That means either the first thing, sine of theta minus 1 equals 0, or 2 sine of theta minus 1 is equal to 0. Okay. pretty simple. Add 1. We've been practicing our unit circle. We love it when it's 1 or -1 because on our unit circle, remember sine is which coordinate, x or y? Y. So if sine is y, am I going to go up, down, left, or right? Up, okay? So this coordinate point is the point 0, 1. What angle is that? Pi over 2, good. So theta is equal to pi over 2. Now, there's only one place where this happens, right? Because that's the only place I go up 1. So this is the only answer for this equation. But for this equation, let's solve it. So if I add 1, divide by 2, I get this. Thank you. Are you gonna go? Now, if I'm thinking of my unit circle,
Sorry of the interruption, staff. Please ignore the bells. You're currently working with Kevin to figure this out. Please, again, ignore the bells. We're currently working with the geo to fix this. Thank you.
where is sine positive? 1 and 2. Good. So let's just think about quadrant 1. Which angle in quadrant 1 gives me a sine value of 1/2? Pi over 6. Okay, so theta is equal to pi over 6. Okay. Now, do you guys agree this distance right here is pi over 6? So in other words, there's another angle in quadrant 2 because that's where also sine is positive, where if I go this way, pi over 6, I should get the same answer. 5 pi over 6, good. So theta is equal to pi over 6 or 5 pi over 6, okay? So to make this look nice, do you guys agree our other answer was pi over 2 from earlier, right? You should technically write them in order just because it looks nice. So our 3 solutions are theta is equal to fancy braces, because we're fancy now. Which is the smallest angle of those 3? Pi over 6, 5 pi over 6, or pi over 2? Pi over 6, so it's going to be pi over 6, comma, pi over 2 because it's in the middle, and then 5 pi over 6. So these are our 3 solutions between 0 and 2 pi. Now, do I have to find the general solution to this problem? Remember, you only have to if I ask you, okay? And trust me, some of these you don't want to because it would be a lot of work. Okay, questions, comments, concerns? All right. To quote Mr. DJ Khaled, another one. All right, so solve. All right, guys, so what should I do first? Add 3. Divide by 4. And then Square root of both sides. So cosine of theta is equal to plus or minus. Do you guys agree square root of 3 is just square root of 3? And then the square root of 4 is 2. Okay. So this one's kind of complicated, but it's really not that bad. So in other words, we want to know between 0 and 2 pi where cosine of theta is positive root 3 over 2 and where cosine of theta is negative root 3 over 2. How many quadrants is cosine positive? There's 2 of them, right? How many quadrants is cosine negative? 2. So you guys agree that there's going to be one answer then in each quadrant. Does that make sense? So really what I need to think about is, okay, well, if I know what theta is in quadrant 1, I just have to use that kind of thinking to figure out what the other 3 answers are. Does that make sense? Which angle in quadrant 1 gives me square root 3 over 2 for cosine? Pi over 6. Good. So this would be pi over 6. And then do you guys agree that this would be 11 pi over 6? And then in quadrant 2, this would be how many pi over 6s? 5 pi over 6 and 7 pi over 6? Does that make sense? Cool. I don't know if it's because of Monday, but some of you guys look very unimpressed. Theta is equal to then what? What goes first? Pi over 6, comma, 5 pi over 6, comma, 7 pi over 6, comma, 11 pi over 6. And then just remember that this is between 0 and 2 pi. So this is our solution set. Now, here comes the tricky part, the general solution. What is the period of cosine? 2 pi. So do you guys remember last week, we would basically just take our 2 answers and say pi over 6 plus 2k pi, and then 11 pi over 6 plus 2k pi. And that was only because, hopefully this makes sense. If I go from here to here, that gap, do you guys agree, is that gap the same distance as it is between those 2 angles? So that's why we have to write it twice, 2 different ways. Pi over 6 plus 2k pi, 11 pi over 6 plus 2k pi, okay? The problem is I could do that here, but there's a nicer way to do it. I could say pi over 6 plus 2k pi, 5 pi over 6 plus 2k pi, 7 pi over 6 plus 2k pi, and 11 pi over 6 plus 2k pi. But you guys notice something about our answers. What? They're all odd, okay? To get from here to here, is that the same distance as it is from here to here? No, right? But what I want you guys to notice is instead of adding 2 pi to get another answer, what could I add to this angle to get to another answer? What? How far apart are those answers? What? Pi. And then to get from here to here, what would I add? Pi. Because how far apart are those? You guys agree those are like halfway around the circle? So what I could do then instead is say my solution set is going to be pi over 6 plus pi, plus pi, plus pi. And then I could jump back and forth between multiples of those answers. Same thing here, how far apart are those angles? Pi. Does that make sense? So sometimes it's really smart to draw a picture because then geometrically you guys can see how far apart they are. These are pi apart, and so therefore I could write that in a nice way, okay? So the general solution theta is equal to pi over 6 plus not 2k pi, but just k pi, because I want to just add pi. Where k is an integer. And then theta is equal to 5 pi over 6 plus k pi where k is an integer. Now, if you guys need help on this, please ask, because sometimes it's confusing. All right. Moving on. All right, so this is kind of like a preview of what you guys are going to see starting tomorrow. Sometimes what to do is not so obvious, okay? So what is a major difference here and then what you guys have seen so far? What's different here? Yeah, are these the same trig function? Wouldn't it be nice if everything was sines or everything was cosines, because then I could maybe factor it or use quadratic formula or do something else, okay? So notice that the slide says using identities, okay? So this is how I want you guys to think about it. I already have cosine, okay? We have an identity that ties together sine and cosine, okay? So this is from last chapter. There was a box that had this. Okay, hopefully that looks familiar. Now, do you guys agree? I don't want sines, right? I want cosines because I have a cosine already in the equation. So what I want to do is I want to solve for sine squared, so that way I can take what's left over and plug it in. So how do I get sine squared by itself? I can subtract cosine squared from both sides. So then I get sine squared theta is the same thing as 1 minus cosine squared theta. So that means I'm going to take this and replace it with this, because they mean the same thing. Okay, so then now that we know that, we're going to plug this in to there. So 3 cosine theta plus 3 is equal to 2 times 1 minus cosine squared theta. Distribute the 2. And then now notice that my equation is just cosines, right? And that's what you want. So in order to solve this, I have a quadratic, so I'd want everything on one side, and I want a 0 on that side. So because this is negative, I'm going to move all of these two terms, I'm going to move them to this side. So if I add this to both sides and subtract this from both sides, I'm going to get this. 2 cosine squared theta plus 3 cosine theta plus 1 is equal to 0. And then this just becomes the same strategy we did a couple problems ago where you factor it, okay? So we're all in agreement that this just means 2x squared plus 3x plus 1. The only difference is it's cosines instead of x's, okay? So multiply a times c, I get 2 and 3. So my magic numbers are 2 and 1. So I'm going to break this up using these numbers. So I'm going to get 2 cosine squared theta plus 2 cosine theta plus 1 cosine theta plus 1 is equal to 0. I want to make sure we're good. Is everyone following? Does this make sense? What should I do next? Do what? I didn't hear you. You want to say anything now? Okay. Don't be shy. Don't be shy, kid 559. What do I do now? Split it? You have to make the sound effect too. GCF. 2 cosine. So I'm going to be left with cosine theta plus 1. Copy paste. What must I put here? A 1. Curious, my kids that had me for math 2. You. Who else? You. Do you remember the little shortcut I showed you guys for factoring? Remind me, I'll show you guys a shortcut. I'll show you guys a shortcut again if you guys forgot. There's a really fast way to factor this. I don't like to teach it anymore because I don't know why it works. It's even easier in the box. I'll show you guys. I just don't want to put it on here. Because I showed other people and let's just say they don't want us to do it. Okay, so what does this factor to then? Cosine of theta plus 1 times 2 cosine of theta plus 1 is equal to 0. So then cosine of theta plus 1 equals 0, or 2 cosine of theta plus 1 is equal to 0. All right, so this is where I'm going to show off my awesome unit circle knowledge. Because I trust that you guys can get to here. But getting the solutions is just as important. So do you guys agree that this means that cosine of theta is equal to -1? We like it when it's 1 or -1 because I see a lot of students make mistakes on these problems though, so just be careful. When you guys do these problems, just think, is cosine X or Y? X. So if I'm X and I'm negative, which direction do I move, left or right? Left. So this point right here is the point -1, 0. Pi, good. So theta is equal to pi. Good job. And then subtract 1. Divide by 2. So then if I'm thinking about my unit circle, and all students take calculus and not consumer math, where is cosine negative? Which 2 quadrants, guys? 2 and 3. So what value in quadrant 1 gives me theta is equal to 1/2 for cosine? Pi over 3. So what is the pi over 3 that's in this quadrant? How many? 2 pi over 3. So theta is equal to 2 pi over 3 or 4 pi over 3. Good job, guys. This is making me happy because last year, I don't know if I like scared you guys into like, please know it, because last year I would just get blank stares in this class from asking the trig stuff. Good. So which angle goes first in order in my solution set? 2 pi over 3. So my final answer is theta is equal to 2 pi over 3 pi and 4 pi over 3. Nice. I would put a star next to that one because something like that may be on your test or quiz, okay? All right. Let's do another one kind of like this. All right, so this is kind of like the one that we just did because notice that I have cosine over here, but I have sine over here. It'd be really nice if everything was either cosines or everything was really sines, okay? So because I have an identity that ties together cosine squared and sine squared, I'm gonna change this to cosines. So if you guys remember from example 7, that sine squared theta is the same thing as 1 minus cosine squared theta. Okay, so I'm going to take this and replace it with that. So if I do that, I'm going to get 12 minus 12 cosine theta is equal to 1 minus cosine squared theta. Now this is quadratic and it's negative, so I'm going to move these two terms, I'm going to move them to that side. So if I do that and make things look nice, I'm going to get cosine squared theta minus 12 cosine theta plus 11 is equal to 0. Is everybody cool with that? Yes, no, C? Okay. So remember, this really means x squared minus 12x plus 11 equals 0. So I'm going to factor it. So what two numbers multiply to give me 11, but when I add them, I get negative 12. Negative 11, negative 1. but it's not x, what goes here and here? Cosine. So I'm going to have cosine of theta minus 11, and then cosine of theta minus 1. So it means cosine of theta minus 11 equals 0, or cosine of theta minus 1 is equal to 0. Wow. So cosine of theta is equal to 11. And hopefully this makes you guys realize something. It's not in a circle, right? Because what's the largest this can be for cosine? If we're graphing the cosine wave, how high can it go? 1. Is that 1? So is this possible? No. So not the entire problem, but just this part of the equation has no solution. So that doesn't mean that there is no solution to the problem. That means that we can still solve this, hopefully, and get something. So cosine theta is equal to 1. So I'm using my unit circle, guys. Remember, cosine is that x or y? X. If cosine is positive 1, which direction do I move? To the right? What angle is that? What? 0. Good. Is that what you said? Okay. So this is my only answer. No? Because 2 pi and 0 are the same spot. So that's why when we do this, see how this is underlined and this is not? Because 0 and 2 pi are the same spot on the unit circle. So up until you get really close to 2 pi. All right. Who made these notes? These notes are long. I have 3 more for you guys, but 2 of them are calculators, so they'll be fast. All right, let's do a hard one. This is where you guys go, yeah, yeah. Okay, what is something that we don't like about this problem? It's trig. Yes, we don't like trig, but it's what? There's 2 trig functions, right? So I have sine and cosine squared. Which one am I going to try to change? Cosine squared. So kind of like the same idea. We know that sine squared plus cosine squared equals. Sorry again. Sine squared plus cosine squared equals 1. Okay. Which means that what could I change this to then? 1 minus sine squared. Same idea. This right here is the same thing as 1 minus sine squared theta plus sine of theta is equal to 2. Okay, I'm going to do a couple steps. I'm going to move this over. What would that be? Minus 1? And then if I'm just thinking in terms of math 2 stuff, when we do factor or solve, we really don't want this to be negative when we can avoid it. So if I multiply everything by -1, that will make this turn positive, and then I'll still get the same answer as before. So sine squared theta minus sine of theta plus 1 is equal to 0. All right. All right, all my cool kids. This doesn't factor. So I have to use quadratic formula. Opposite of b plus or minus square root b squared minus 4ac all over 2a. Hey. So what's a, guys? What number's right here? 1. What's b? -1. And what's c? 1. Technically, I should say theta. My bad. Theta equals, because we're solving for theta. What's the opposite of my b? 1. So 1 plus or minus the square root of b squared minus 4 times a times c all over 2 times 1. So if I'm just doing mental math, when you take a negative and square it, it becomes what, guys? Positive. So do you guys agree that's just 1? 1 minus 4 times 1 times 1. What's 4 times 1 times 1? 4, right? So this just becomes 1 plus or minus 1 minus 4. Do you guys agree is negative root 3? All over 2. What's wrong with this? Okay, what you said? Negative inside a radical, which means what type of answers are we going to get? Imaginary. Hey, guess what, guys? We don't want imaginary solutions. Not until chapter 5. So, does this have any real solutions then? No. So this means the solutions are imaginary. Which means, therefore, this equation has no real solutions. Okay. For this next example, you guys will need your calculators. So can you guys take out your calculator? Okay, I'm recording this, so if you guys need to see this again, my students that are taking AP Calc with me next year, this is something that we do all the time. We solve equations by using our calculator, okay? So we don't have to do really any math here. It's just knowing how to use our calculator. We agree that this means that this is equal to this, right? So we're trying to figure out which X values make this true. So number one thing that you need to do right now is go to your calculator. Can you guys make sure it's in radian mode? So go to mode, just make sure it's not in degrees, and go to second quit. In order to solve this using our calculator, we're gonna graph this. So we're gonna do a couple things. I want you guys to type this into y1. So go to y equals, type this into y1, and just remember that there's really a parentheses around this x. Do you need a calculator? It's already in radio mode for you. Yeah. And then it's equal to this, so this is going to be my y2. Okay? So while you guys do that, I'm going to set mine up too so you guys can see what I'm doing. What was it? 5 sine of x plus x? And then 2, 3. Okay. Now, a couple things. We usually solve these between 0 and 2 pi, right? So what I want to show you guys is if I go to window, so if you guys click on window, I'm going to make the x min not 0. I'm going to make it like a little less than 0. So I'm going to type in negative pi. If you guys just go to second and then the caret key, you go to negative pi. And notice your calculator changes it automatically. That's pretty cool. And then I don't want 2 pi in case one of my answers is 2 pi. So I'm going to go a little bit past that. So I'm going to say my x max, I want it to be 3 pi. And then I'm going to go ahead and hit graph. And there we go. Okay, are we paying attention? Because this is a really important skill. Even if you guys go to college and your professors allow you to use a calculator, this is a good skill to have to check your answers sometimes. So the answers, guys, and juniors, when you take the CASP, if it ever says to solve something by using a graph, the solutions are wherever they cross, okay? So do you guys agree it crosses here, here, and here? So the way that we figure that out is by using, write this down in your notebook. You're gonna do second, trace, intersect. Okay, now here comes the cool part. Your calculator is really smart. So number one, if you guys go to your y equals, it should show you which color is what. So the blue curve from my calculator is the sine curve. The red curve is the 3. So I want to know what this solution is. So all I have to do is go over really close to where those two cross. And then just hit enter, enter, enter. And that value right there is my answer. X is equal to what? 0.591-ish? 519, sorry. I'm dyslexic. 519. And right here, when I post your notes, guys, I'm going to post this graph so it looks nice. So X is approximately 0.519. X is approximately... So can you guys do the same thing to figure out the other one? So go to second, trace, intersect. And then just move your cursor close by that second intersection. And then just hit enter, enter, enter. And did you guys get this? Yeah? Okay. 3.177. And did someone find the last one? 5 point something? What's it?
5.710.
Okay. Cool, guys. So when I post the notes, I'm going to post the graph so you guys can see that as well.